Hello, can you hear me? Okay, so now we'll start. So, hello everyone, I am Rajiv Ranjan and I will be taking the live sessions. Today is the week 3 live interaction session of Field Structural Geology course. So, we have had two courses, two, 2 weeks of live session. Today is the third session, and the fourth and the last one will be next Sunday. So, let us start with the course outline. So we know that we have been studying field structural geology. So we have covered week 1 and week 2. Today we will be covering week 3. So we studied ductile deformation, superposed folding, overprinting relationships, and in this we have, if you have gone through the lectures, we have learned about classification of folds, basics, and classification, superposed folding. So this is a summary of week 2. So in the first lectures, where it has been shown that how to do lithostructural mapping. So followed by that, we have studied the basic concepts of folds and folding, which includes concepts and definitions, importance of studying fold, elements of single layer fold, and then we studied classification of fold based on different. I have just listed a couple of uh, classifications types, but we know we have more than that. And then we studied superposed folding, where we learned how superposition happens, and we studied morphology and classification of folds. And at last, we studied Ortco patterns and superposed fold. And there is slight ductile deformation of interaction, which will be discussed mainly in the this will be week 3, huh? Not week 2, week 3. Okay, so now we will start solving the problems. So in the meanwhile, if you have any questions, if you're in dots, you can raise your hands or directly unmute yourself and ask if you face any issues. Okay, so let us begin with the first one. In geological terms, what does term fold primarily refers to? Option A break in Earth's crust. Option B, a bending of rock layers due to stress. Option C, process of erosion. Option D, a type of sedimentary rock. So what do you think? Which is the best option? Which is the correct option? So a break in the earth crust is not necessarily, we call it fold. It can be different manifestations. The bending of layers rocks due to stress. So this is the, yeah, Sumit.
Should be option B, bending of
Why?
rock
Why?
layers due to.
Why do you think option B? Why not A?
No, it is not actually break. It is
Mm-hmm.
not break when
Mm-hmm.
one rock layer bends due to stress or due to tectonic force, and it overimposes on another layer that is called fold.
Yeah. So primarily, if fold refers to, we know that, curved surface or, bending of surface. So, but one important thing to note when we are saying folding in terms of geology, it should be related to deformation. And deformation means that it is a manifestation of stress, right? So that is why option B is Correct. Okay, let's move to second question. Why fold is or are important? So this is multiple correct options, so please choose wisely. So what do you think? Option A reveals 2D and 3D geometries for its economical importance, reveals tectonics processes history of the past, reveals kinematic and mechanics of the deformations. So what do you think? So here if we see, it would be here all of them are correct. So we know fold, if we study fold, it will help us to understand, the 2D and 3D geometries of the structures. And we know also for economical importance, why we know that, especially if you talk about, you know, oil industry, uh, oil industry, we know that if you talk about anticline fold, there, what happens? It acts as a, how does it help? Sumit, you're saying something? So, so suppose this is a fold. Huh. So, oil and gas comes and get trapped here. Hmm. So, this is how it helps. And not only that, it also helps to deposit minerals, mineral deposition, mineral depositions. Okay, so actually I got cut. So that is why if you talk about tectonics processes and history of the past, we know what it helps when you study fold and its deformations. It does helps. And also for kinematic and mechanics of the deformations. Hold on a second. Okay, so it helps us to, it reveals also kinematic and mechanics of deformations. This will be, part of a structural geology course. So if you go through it, you will learn, especially if you study advanced structural geology, hmm, where you will learn in details. Okay, which of the following is not an element in a single layer fold? So we learned through the lecture there are several elements of a fold. So what do you think? Axial plane, hinge, line, limbs, bedding plane. Which of these following is not a element of a single layer fold? So we can see axial plane if we have a fold. Hmm. Just I'm trying to draw a 3D. So we know what do we know? It has, so this is axial plane. We know axial plane is an element of single layer fold. Then hinge line. We know what? This is a hinge line. Then come limbs. We know fold has two limbs. So this is correct, this is correct, this is correct. Bedding plane. Bedding plane is not a element of folding. Why? Because when bedding, you know, folding, fold or folds are results of bending bedding plane, right? So when you have a plane, bedding plane, and then it is, if it's get folded for some different types of stresses orientations, then it becomes a fold. So that is why option D is incorrect. So I have kept one photos here. Okay. First we will try to solve this question, then we will discuss the from the image. The line that separates the two limbs of a fold passes through the point of maximum curvature. Is called what? The line which separates the two limbs of a fold and passes through the point of maximum curvature is called what? It is called that line.
Axial plane.
I'm talking about line, not plane. Oh,
Oh, sorry. Hinge line is the maximum point. Hinge is the maximum point of curvature. Point of maximum curvature. Fold trace. Fold trace. Fold trace, I think.
anybody else? No. So axial plane is something we here talking about line. So axial plane is not that line that separates two limbs. It does separates. It's a plane, right? If you see here, so that is why I have kept this image. So if you see here, this is the axial plane or surface, right? So this is separating two limbs, this one and this one, but that is not a line, right? So option A is wrong. Hinge line. If you talk about hinge line is something, and all important thing is that point of maximum curvature. So hinge line is a point of maximum curvature. We know that. Fold axis is does not fold axis because fold axis lies everywhere, right? If we have here, you can have here also in going through like this and like this. So fold axis is not something which divides these two limbs. Fold traces, no. Fold traces, right? What? It's a traces. You cannot. It does not actually divides. So that is why option B is correct. Hinge line is something which separates these two limbs of the fold. Okay. So I have kept this image also to help you to understand basics, elements and all. So if you see here, this is a fold. This is a fold. So there are several elements that is actually mentioned here. If you see, first thing is you should know about that. So suppose this is a trace of the fold. So we know that fold has two limbs, right? When that two limbs makes it as a fold, right? So this is one limb, so that is it is mentioned here. If you see limb, right? So this is one limb, and this is second limb. So that limb is something which we have two in a fold. Axial trace is what? Axial trace is the trace of this axial surface. Huh. Axial trace is the trace of this axial surfaces. Hinge point is what? Hinge point is the point, you know, of that line. If you have this hinge line, suppose this is the hinge line, this is the hinge line of this fold, right? So this point would be in the profile plane. If you look at the profile plane, which is perpendicular to the hinge line, that point, it will appear as a point, and that point is known as hinge point. And if you have multiple points, hinge points, so suppose if you have a layers of folding, multiple layers, so you will have numbers of hinge points, right? Then comes this hinge zone. So we know that limbs are on either side of the fold. So zone is something which the area of higher curvature. So very near to the hinge lines. So these areas are called hinge zone. Very close to the hinge line, very close. Inflection line is something which marks what, or divides the transition between the convex and concave part of the limbs. So if you see here, it's actually this line, inflection line, is dividing these limbs into two. The first is, and second type is this. So you can see here concave up, and here is convex. So this divides. Amplitude is what? Amplitude, we know in general language also, we know the amplitude is, what is the amplitude? From the median line, this would be, if you look at the profile plane, suppose you have a fold like this. So this is the inflection point, right? So, okay, let me, sorry, I have a terrible handwriting, drawing especially. So please bear with that. So this is the amplitude. And it will be same, right? So now comes the interlimb angle. So interlimb angle is something that the limbs makes. Suppose this is the two limbs, one limbs and two limbs of this fold. So the angle which it makes, you extend this like this, and if you extend like this, so this angle is known as interlimb angle. I hope you have all gone through all these things. So I just wanted to go through so that you understand. So you want to say something, Sumit?
So actually, somewhere in the study material, I have read. I don't exactly remember where. The hinge line is the line which wherein the curvature of the fold appears as a straight line. Yeah,
Hmm.
am I correct?
Yeah, you're correct. You're correct. So if you see the curvature here, you can see this curvature as a straight line, right? The maximum curvature, right? That becomes when it becomes almost horizontal. So this is the point of maximum curvature, right? These are the points. So if you connect this all these points of this plane, it becomes the hinge line. Hmm? You are correct. You are totally correct. So I've just kept these figures. Okay, we'll go to later. Now it's not time to dig into deep into it. So okay, let's solve another problem. The imaginary surface that bisects the angle between the two limbs of a fold is known as, just discussed. I just discussed. Axial plane, hinge line, fold axis, fold trace. We just studied that axial plane, right? If you remember. So this is the axial plane, right? So this is dividing. This is the surface, right? We are talking about now surface, which you were saying previously, Sumit. So this surface, this is the axial surface, and which is also known as axial plane. So this is the correct. Line is not the correct option, right? We discussed this last in the last question. Fold axis, something which is a line, not a surface. Fold trace also a traces, so it's line, not surface. Okay. The intersection of the axial plane with a horizontal surface is called first. Yeah, Smita, please. Smita, you want to say something? Please go ahead. Am I audible to you? Axial fold. What is it? Can you speak? Okay, so first option is hinge lines, second option is fold axis, third option is fold trace, and last option is fold plunge. So now we will try to draw this figure. Huh? The intersection of the axial plane. So we have a fold. Just give me a second. I have to check something. Really sorry. Sorry for that. Yeah. So now let's try to intersect. So we know this is the axial plane, right? This is the axial plane. And if you, so now make a horizontal surface. So suppose this is a horizontal surface. Terrible, terrible, terrible drawings. Yeah. So what will it give? The intersection is, what is the intersection? So intersection is this one. So this is the intersection, right? This is the intersection, isn't it? So what will it give? It will give, tell me, anybody?
Hinge line.
Hinge line. Correct. Okay. The angle between the axial plane and the horizontal is known as, I discussed in the last class also. The angle between the axial plane and the horizontal is known as dip, plunge, rake, or pitch.
Should it be plunge of the fold?
think, little bit think. Here we are talking about angle between the axial plane.
Then it is deep of the axial plane.
Okay, let me draw for you. Let me draw for you. So, suppose this is a axial plane, huh? And you have this is the horizontal. Now the question is asking the angle between what? This axial plane and the horizontal. So this angle, right? Right? Tell me. I hope you are with me. Yeah? Are you with me? Are you following what I'm saying?
Yes, 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 of course.
So this would be the angle, right? This is the angle which I'm talking about, or the question is asking.
Yes, yes.
So what is this angle? See, okay, let's go one by one. Plunge is something. Okay, let's go pitch. Pitch and rake is something which we deals with lineations, right? Linear features. And pitch or rake is measurement of the lineations based on either based on second time. Either based on with respect to the strike or with respect to the hinge line or hinge fold axis. So this is something is wrong. Plunge of the fold is what? Plunge of the fold is the hinge line, the the angle which makes the hinge line with respect to this horizontal. So correct option is A. Sorry, Sumit. So I wanted you to think a little bit so that you understand the problem. Yeah, right. You are right. Correctly right. The
Sir,
option A is
in this case, the plunge of the fold is the angle above the horizontal plane.
sorry. Sorry.
Plunge of the fold. Plunge of the fold. Yeah, in my
Mhm.
opinion, plunge of the fold is the angle just opposite. I mean,
This
uh,
see here the plunge of the fold is what 0. If you talk, see if I make this, if I make a okay. So let me. So if this is the fold, huh, right? So the plunge amount will be 0, right? Right.
okay, 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 okay.
I hope you get it. Right. Hmm. Okay. Okay. Let's move to the next question. The angle between the hinge line and the horizontal is called. Hmm. Now comes what you were thinking. Do it. Deep of the axial plane, plunge of the fold, rake of the fold, or pitch of the fold. So this is angle is talking about the angle between the hinge line. We discussed, right? We discussed right now. What is it? Sumit, what will be the answer?
This is the plunge. This is plunge of the fold.
Correct. Okay, let's move to the next question. The angle between the strike of the axial plane and the hinge line is known as.
Please elaborate on this. I you know that I am weak on this fundamental.
I understand. I just want you to think a little bit. Just try to think. So here it's asking that the angle between the strike. So suppose this is the axial plane. Hmm. This is the strike of the axial plane with this, right? Hmm. So this is the strike of the axial plane and the hinge line. So hinge line would be like this. Suppose here we have 0. Hmm. But but if you think, if you just imagine, try to imagine that you have let's take at a different angle. Huh? Like how should I take it? Okay, let's take another. Hmm, like this. It will go like this, something like this. So the angle between the strike and so the trace will be what? Now the trace will become the strike of this axial plane will be. So this is the angle that we are talking about. Huh, this theta. So this is called what? Dip is incorrect, plunge is incorrect, either rake or pitch. So the angle that we measure on the, so there are two terms. Important thing is rake and pitch. Huh. So rake is uh, generally in terms, we talk in terms of fault, huh? Lineations on fault, and pitch we talk on related to fold. Hmm. So what will be the answer? Sumit, now you understood the, I have explained the solution as well,
The pitch.
right? Just 1 second, 1 second, 1 second. I just told them really sorry. So it's just the opposite, huh? Sorry, I'm really sorry. So rake is for fold and pitch is for fault plane. I'm really sorry. Hmm. So the correct answer is C. I hope you got it. Right. So rake is for fold. Huh. You remember last time we were when we were trying to solve this, stereo problem, stereo net, we were having some questions on, rake, right? You remember? So we were having some rake on the limbs. So this is related to fold. Okay. Which of the following is the characteristic of anticline fold? Option A, the limbs dip towards the hinge line. The oldest rocks are found at the core of the fold. It is formed by extensional forces. It has a concave upward shape. Which is the correct option? Anticline. Anyone? Shaker? Okay. So now try to draw an anticline fold. Hmm. Here we have, this is an anticline. Hmm. So older in the core and younger on the top part. Hmm. So here if you see the limbs are how the limbs are dipping. It's not dipping towards, it's dipping away, right? It's dipping away. So option A is incorrect. The older steps are found at the core of the fold. See, older form is the root. So if you have, went to the slides or lectures, so we know. So what will be difference is that in syncline, anticline and syncline, right? There are two there are two types of fold based on the older or younger, whether in this the core. So in an syncline fold, what will happen is younger in the core and older on the outer part. So this is called syncline. And there is another one, which is whether it is antiform or synform. So this will be based on the closure. This is based on the closure of it. So if you have, wait, sorry. So this is what the closure is. This dipping is away, right? So this is an antiform. This is also dipping away. So this is also an antiform. Antiform syncline and antiform anticline. But if you have, suppose you have this synform. Hmm. You have here younger, here you have older. So this is what? Syncline and synform. Now let's consider a different scenario. You have why syncline? Because younger is in the core. Why synform? Because both are dipping towards each other. This is why synform. Now you have older in the core and younger outside, right? So with this younging or older, due to the age of the this layer, this is what this is. What is this? This is anticline or syncline? Since this is dipping towards each other, this is a synform, we know, right? So whether it's a syncline or an anticline. So if you see here, to be an anticline, the older has to be in the core. So here the older is in the core. So that is why it is anticline synform. So these are the four basics classification of the folds based on the younging directions, older younger, and based on the closure of the folds. Wait. Discard. Sorry. Hmm. So now you have studied, you learned this. Okay, now try to solve this question. What type of fold is characterized by both limbs dipping in the same direction? Tell me. Anticline, syncline, monocline, or overturned fold? What do you think? So we studied, right? Right now we studied anticline is based on the younging or older. Basically, it's based on age. So this is incorrect. Syncline is also based on the age. Overturned fold, what do we know? Do you know anything? So monocline. So have you seen such fold? Have you seen no like this fold? Suppose so this is so here the question is both limbs dipping in the same direction. So an example of this would be synform. Synform is an example of right both limbs dipping towards each other. So there is another type of fold which is called monocline. Monocline. So in monocline type of fold, what happens is you see this. So this is an example of, or it could be a little bit like this. This is an example of monocline fold. So if you see, little bit it goes like this. So this is dipping in the direction, this is dipping in the direction. So both of the limbs here is dipping in same direction. And overturned fold, what we know that one of the limbs gets rotated more than what 180-degree, right? So if you have a fold like this, if you have initially if you have a you know like this, so you can have a fold like this, you can have a fold like this, and beyond when it goes beyond this 90-degree, this is called, so this limb becomes overturned. So this is an example of overturned fold. Got it? Okay, let's move to the next question. Which type of fold do the limbs dip away from each other? I think this sort of question you have done a lot. Let's move to the another problem. I have just described this overturned fold. Both limbs dip towards the hinge line. One of the limb is tilted beyond vertical. The fold has a symmetrical shape. It is formed under a compressive stress. What do you think? Nobody?
Option B, one limb is tilted beyond vertical.
Correct. Very good. Let's move to the next question. What is the primary cause of folding in geological formation? Again, the same question.
Tectonic forces.
Correct. We have seen weathering does not cause, right, to form folds. Sedimentation is not cause of fold. Erosion is something which is does not leads to any fold. Okay. Select the correct option which properly distinguishes chevron folds and king folds. If you have learned the classification of fold based on the limb geometry, then you will be able to understand this question. High roundness and tightness and limb symmetry, only hinge roundness, only limb asymmetry. So what distribution which means chevron folds and king folds? So chevron fold is what? You know chevron folds, right? If you have seen this sort of fold, right? Now, if you come to, or in other way, have you studied chevron folds, Sumit?
Sir, I've heard it. Somewhere heard it means I have read about it, but I don't exactly remember it now.
Okay, okay, no issues, no issues. So, chevron folds, when you have, you know, very symmetric, very, very at an angle. Hmm. And especially it is characterized based on a very straight limbs. Huh? Right. But when it comes to king fold, it will be like this. We have here symmetry. We can see the symmetry. Here we have asymmetric. Right. Here it's straight, but it's asymmetric. This is king fold. So it's based on not hinge oneness, not tightness, not, you know, asymmetry. This. So only the limb symmetry. Here we have asymmetrical limbs. Here we have symmetry with straightness. Okay, so this is the based on the limb class. So this is a very good question which will make you think. Huh. So figure X and Y profile sections of folds traced by two cross-bedded sandstone beds. Which of the following the correct interpretation? I have just explained. So now you have to use these cross beds, to interpret this solution. Just think a little bit and then try to answer. I have explained, right? I have just explained antiformal, syncline, synformal, you know, antiform. Everything I have explained, overturned, So try to think and then answer.
X is antiformal. Sorry, X is antiformal, and Y is informal.
Why are you saying X is? And
Sir, what is the core? What is the core and what is the young limb? I'm sorry, but
uh, so for that, you studied in the last lecture, These are what are these? How will you? What is the significance of these cross bits? Do you know that? You know these cross bits, right? You know the significance of cross bits. Last class I discussed, right? If you remember. Don't remember? So I told you last day that this asymptotic bottom actually gives us that this is the stratigraphic bottom direction, huh? And this is gives you this is the top direction, and this is bottom. Now use this and then tell me. Do you understand? Sumit, did you get it? So if you see here, see, this will give you actually top and bottom. So now you will see which one is older and which one is younger, right? So here you can see that this is bottom, right? So bottom means what? This is older and this is younger. Here bottom is here. So this is older and this is younger. Now tell me which one will be anticline and which one will be syncline. Still not able to differentiate. So you learned that when the older is in core, what does this mean? Anticline or syncline? Tell me, Sumit, anticline or syncline? It is a
If it is
syn and
away from the core, then it is anticline.
no. See, older in the core, that means it is an anticline, right? That we discussed here, right? If you see, where did I discuss? I deleted it, I guess. Okay. So this is what I discussed, that when you have older rocks in the core, that means this is a normal scenario, right? This is an antiform. It is an antiform. Here, if you have older, and so it also becomes anti antiform and anticline. Now, in normal synform scenario, this is a synformal. Here it becomes younger, and here it is older. So this becomes also syncline. But here, if you see, it's just opposite, right? So just think very simple. If you have older in the core, anticline. So y is anticline, and x is what? Syncline. And now look at the closure of this fold. So both are dipping away, right? Dipping away. Limbs are dipping away. That means what is it? Synform or antiform? It's an antiform, right? And here both are dipping towards each other, means synform. Now try to see which is one is correct. Smita, would you like to say something? Which option is correct here? I have solved the question. So option D is correct, right? X is antiformal syncline. Syncline and antiformal. And Y is anticline and synformal. Anticline and synformal. Did you understand, Sumit?
So it is a little confusing. But what should be the basis? Should be I mean, which is the older one, older layer?
See, did you understand this cross beddings? This cross bedding? So you know this cross bedding is a sedimentary structures and this is primary structures, right? Primary structures. So this asymptotic, this asymptotes gives you, this means that this is bottom and this truncated top gives you top. So wherever you have this cross beds, so this asymptotic bottom means this is the older one. You can see here, right? You see here, this is older. Bottom means older. So that is why here becomes older. And this truncated means top. Top means younger. Do you understand? Not still not? Tell me, I will help you.
Sir, please tell once again.
Ha. Okay. I will draw once again for you to wait. So suppose You know crossbeds. So crossbeds are nothing, which is basically the initial ripples, or you know the sedimentation due to the wind movements. The sediments go, deposits, and it forms what, like this, right? Right. It will get deposited, and what happens, and then if you have a wind, this will, like this, it will keep on forming like this. So this is why this bottom part, so wherever you see cross beds, wherever you have this asymptotic part, this becomes the bottom, and wherever you have, so later what will happen, it's like this. Suppose you have like this, so it got cut, suppose it got eroded away this much. So this part got eroded, so what will be left? It will become like this, right? So you can see the bottom part is asymptotic, right? So this gives the bottom, and this tells us, really sorry, this tells us what? This is the younging direction. So this is younging, and this is older. So if you use this cross base as top directions, to find out stratigraphic top, so you can see here, what you can see here. Now let me delete everything. Where will be direction towards, so this will be, right, stratigraphy top. So this is top and this is bottom. Now understand, Sumit? And
Yeah.
here, this will be
Okay.
top and this is bottom. Now do you understand?
Okay.
Yeah. So option D is correct. Okay, very simple question now. What type of fold has limbs that are nearly parallel to each other? This is classification based on the interim angle. Option A, open fold, tight fold, isoclinal fold, recumbent fold. I think I have put some figure. Yeah, good. Tell me.
Isoclinal.
Isocliner. Very correct. Okay, I will explain you with this next figure that I've kept. So if you can see here, based on the interim angle, this is gentle when you have 182, 200, 120 to 70 becomes open, then close 70 to 30, then tight 0 to 30, and isocline becomes parallel to each other, 0 degree. Okay, now comes interesting one. Which of the following option is not true for a parasitic fold? I hope you all know parasitic fold. Option A, parasitic folds are second order folds formed due to buckling of the regional fold. Parasitic folds are asymmetric folds that form due to shearing of the limbs of the regional fold. Parasitic folds are second order folds formed during the same deformation event that produced the regional fold. Parasitic folds are higher orders fold which have smaller wavelength compared to the regional wavelength. Yeah, what do you think? You know parasitic folds. I hope you know parasitic folds. Have you studied, right, Sumit? Parasitic fold?
No, sir, I don't remember.
Okay. Okay, let me then first explain it, then I will go back to the problem. Hmm. So this is the image. So this actually tells you what parasitic folds. So here, this folds, this is smaller, and these are called higher order fold. These are called parasites, parasitic fold. You know parasites, right? In biology, we know parasites, which depends on other one, right? Parasites. So it is called parasitic fold. Why? Because it is. So this is the, if you see here, so this is a higher order fold. Hmm. I mean, this is the larger fold. Huh. This is called first order fold, and these are called second order fold. And if you can have, one more layer, even in within this you can have another fold, right? It is possible. So this will become third order fold. Now, so there are versions, huh? So you can see this larger one, and these are smaller ones. So here you can see it appears like a Z. Here if you see it, it appears like S. So to understand this Z on S, you can see when you have a clockwise, huh? L, long, short, long. You can see, right? Long, short, long, long, short, long. Here, long, short, long. So here you have anti-clockwise. Here you have clockwise. So this also gives you vergence. So these are called Z, and this is called S separate. And these are called parasitic folds. Parasitic folds means it is dependent and it actually mimics the higher order fold, makes the first order fold. Huh. So if you have to, extend this fold, it would be something like this. Hmm. And this will continue. Hmm. This will continue like this. So now try to come here and try to solve. And if the interesting part is what? This parasite folds, if you have the largest fold, like this becomes symmetry. If you see here, symmetry. You can see the symmetry, right? You can see this. This is what actually giving you. Now comes to the question and try to solve it. And one more thing. So you can see what that larger fold has what? Higher wavelength, right? And higher amplitude. However, this higher order fold have a smaller wavelength and a smaller amplitude. I think now you will be able to solve this question. Now try to solve this question. Not still not. Now, okay, let's read first option. Parasitic folds are second order folds formed due to buckling of the regional fold. What do you think? This is correct or incorrect? Sumit?
Sir, what is the exact morphology? I mean, which comes later? Which comes earlier?
Okay.
Which comes?
Okay, what happens? Okay, I will draw here for you. Okay. So suppose you have a layers. Hmm. Now it gets, suppose you have a tectonic stress orientation in this manner, in this way. So what will happen? The buckling will occur, or the folding in simple term, fold will occur, right? Yeah, Smita, you want to say something? But because of, oh, there is a best experiment actually, So an experiment was done. I hope, I wish I could show you that experiment. So in that experiment, what is how it has been shown that suppose you have a block of rock, in that you have a, very fine, layers, which is of different. The mineralogy is different, huh? So now when you try to compress this, what will happen is that, what can you can imagine that the larger block is first, it will shorten, huh? So it will get thickened, but a smaller one will get, try to, it will start getting folded, huh? So similarly, what happens here is that due to this shearing, or due to this stress conditions, it forms a larger fold. But because of some inhomogeneity in the layers, if there is some smaller layer, this will easier to, you know you can, I don't know if you are able to understand, otherwise I will give you separate different example. So if there is some inhomogeneity in the layers, they will try to, or very thin layers corresponding to this thicker layer, so they will also, start getting folded, huh? And what they do, the interesting part here is that they mimic of what, mimic this, the larger folding geometry, and this is actually known as Pumpelly's rule. Hmm. Pumpelly's rule. So this is nothing but this is an example of Pumpelly's rule. So Pumpelly's rule suggests that the higher order of folds will mimic the lower order of fold. What does that mean? That means they will also form this folding. So this is what the morphology that you are asking. I hope you have little bit better idea now, Sumit. So option A, which is parasitic folds, second order. We know parasitic folds are second order folds, and these forms can be due to the buckling of the original fold. So the regional folds found due to buckling, and because of that also the second order folds formed. So option A is correct. Option B, look at option B. Parasitic folds are asymmetric folds that form due to shearing of the limbs of the regional fold. What do you think?
So this one also seems to be correct. Parasitic
Okay.
folds are.
Okay, let's move to the third question. Third option. We'll come back. We'll try to understand. Okay, third option. Parasite folds are second order folds formed during the same deformation event that produced in the regional fold.
Yes, it is correct.
Hmm. Okay, option D. Parasitic folds are higher order of folds which have a smaller wavelength compared to the regional fold.
This is incorrect.
Why?
Because they have their wavelength, their wavelength,
So I'm
frequency.
talking about the parasitic folds are higher orders which have a smaller wavelength. So I just to show you which one has smaller and which one has higher wavelength.
The lower one, lower ones
The
have smaller wavelengths.
so the higher order has. right? The higher order of folds are smaller wavelengths, right? You are not getting it. I'm thinking, I'm guessing that you are not understanding it. So I just told you that this is the first order fold, right? This is called first order fold. Huh? Just remember, this is the first order fold, and this is second order fold. So this is called higher order, and this is lower order. So lower order has larger wavelength, right? And higher order fold has, well, it's just this much. So higher the order, higher the order of fold, lower the wavelength and amplitude, and vice versa, and vice versa. I hope now you understand. So now it will be clear.
Parasitic folds are not higher order folds.
Parasitic folds are higher order folds.
Okay. Okay.
And remember, parasitic folds formed at the same time, huh? Not at different time. That is how it mimics. That is why. So here option D is correct, option C is correct, so option A is correct. But it's not due to the shearing of the limb. First, it doesn't happen like that. The limb, the first order fold formed, and then because shearing, no, it's not because shearing. It's shearing of this layer. This is possible that shearing of this layer would lead to form, but not the limbs. So that is why option B is incorrect. Right?
Okay. Okay.
Okay, good. Now let's move to another question. Choose the correct option that describes the competence contrast of the layers in the figure below. So we have here, so this is a fold. Last time we discussed, in the last class, I discussed this cleavage refractions. So this is a fold layers. This is a layer D, huh? And this is another layer C and C. Huh? B, B, C, C, and D are A. So this is the cleavage. Huh? This is the axial planar cleavage. This is axial planar cleavage. Hmm. Now try to understand. So it talks about the competence contrast. So what do you think? Which one has higher competence? I will just give you a hint. So here you can see there is larger deformation that has happened, huh? Right. Otherwise, this would have been straight, right? This would have been here. This would have been here. It would have been here. But you can see there is larger deformation that is happening in layer A, right? So now try to see the options and mark the correct options. Option A is A and D are high competence rock, and B and C are low competence rock. So A and D. So higher the competence, what does that mean? That means that it will be harder to deform. So there will be less deformation in more competent rock. Or you can understand in this way that more competent rock is lesser competent rock are easier to deform. Now you can see this diagram and try to understand, try to answer the question. Are you with me, Sumi?
Hello.
Yeah. So are you following me? Are you able to follow me what I'm trying to say here?
Sir, in the left diagram, is it
Mm-hmm.
B the higher layer and A the lower layer?
It's not higher or lower layer. So, just imagine that this is the initial scenario. Huh? Initial scenario is like this: A, B. Huh? So some forces, acted here, and then it got deformed.
Then what does A and B actually represent?
So these are two layers. I mean,
This is,
okay. Let me do one thing. So
is it,
suppose
are they the cores and the young layers?
no,
Like
no, no. Don't think about core and here. It's not to deal with any. I mean, there
no,
is no relation between core and.
no.
So you can have okay, in that sense. So okay. In that sense, this is core. This is what do you say? Outside, outer core or inner core? Yeah.
In that case, B is more competent and A is less competent, and C just the vice versa. I mean, C is more competent and D is less competent.
Okay. Are you able to match with any other options?
B and D are high competence. B and D not B and C. B and C, no option is there.
No option is there, right?
B and C. B and C. No, no, no. Option A. Option A is correct. A and D are high. No, 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 no. Sorry, sorry. Mm, what is that? Yeah, yeah. Sir, you have just said that in case of more competent rocks, should I say rock or layer?
Layer or rock, you can also say layer.
In case of higher competency, the curvature will
It
be
will be
less.
it will be
Curvature,
difficult to deform. Yeah.
should I think in terms of curvature? The curvature will be less. Curvature will be more like that. Deformity, okay, okay, fine, okay. Deformity is also okay. Deformity would be less. In case of B and C, deformity is less.
Right.
But there is no such option. In case of B and
Mm.
C, high competent, high, I mean, of high competence, it's not that.
Okay. Okay. Let me do this. I wanted to keep one figure for this to help you to understand. I have not kept it. Somehow I guess missed it. Just give me a second. I will just put one image. I think I showed you in the last. One second. I will just put it. Just give me a second, and then I will help you. It will help you to understand. Mhm. Do you remember last time I discussed fanning of cleavages? Okay.
Yes, yes, yes.
Wait a second. Which one I should take it? Hmm. Copy image, and then let me put here. Okay, it should be here. Can you see now? Can you see?
Yes, yes.
Yeah. Now try to understand this. Huh? So this is convergent cleavage fanning, and this is called divergent cleavage fanning. So everything is getting converged, right? Now try to see here. Convergent cleavage fanning in coarse grain relatively competent wet. Huh? So in competent wets, what happens? Convergent cleavage occurs. So if something is converging, getting converged, this suggests what? That it is a competent wet. Divergent cleavage fanning in fine grade and incompetent rock layers or beds. So if you see this image, so what are you able to see here? Which is more competent, which is less competent? What do you think?
Convergent is convergent is more. Sorry, less competent.
Hmm.
Convergent is no, 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 no. Convergent is it is compressing more. That means I'm not getting the idea.
So basically what happens here, okay. Just hold on. Let me explain you. So, okay, now suppose you have three layers, huh? I will get to the basics. You have layer A, layer B. Okay, take one more layer. Have three. And you have axial planar cleavage like this. Hmm. And now for C. Okay, do one thing. Wait a second. Okay, let me make for you. Hmm. Sorry for that. Now imagine that you have these are the axial planar cleavage. Huh. And to better replicate this, let me delete this. I will. It will more replicate and help you understand. Now suppose you have a shearing. You have a shearing this way, and imagine that this is more competent, huh? This is competent, and this is less competent. So after shearing, what will happen?
Sir,
Here,
just one basic thing. One basic thing.
hmm, hmm, hmm.
I mean, in general terms, what does
Yeah,
more competent being mean?
more
Does it mean
components
more?
is difficult to deform. It's very, you can say in simple words, it's hard to deform.
That means it is inelastic. I mean, comparatively inelastic.
Yeah, ah, you can say it's very high. It has high stiff. I mean, it has stiff, brittle in nature. You can say. I mean, not exactly. It's very. These terms are very, critical to use. But you are getting the point. What I'm trying to say. So that higher competent rocks are not easy to deform or easy to flow. You can relate it to in terms of viscosity. So you have higher viscosity means what?
To
It has
have
more resistant, right? Resistance to flow, right? Right?
resistance is low,
Higher viscosity means resistance is what? High, low.
high. Oh, sorry,
High.
low. Resistance is low. No, not very much. Not very
High viscosity means it's not easy. It has very high resistance to flow. For example, so water has a high viscosity or low? Tell me, you will understand this. Water has high viscosity or low? Compared to what? And so tell me, air or water, which is more viscous? Or water or honey, which is more viscous?
much. Water.
No, your conception is wrong. So, no, it's just opposite. Sumit, it's just opposite. So, higher viscous means it will have more resistance to flow. Huh? Lower viscosity means it has less resistance to flow. So, water is less viscous. Honey is more viscous. That is why when you drop a honey, it tends to flow a little bit, huh? Then it drops. But if you just drop a water, it just flow easily. So that is why it has lower viscosity. So that is why in terms of viscosity contrast also in competent means you can say that it is high viscous or viscosity. So there is another term which you say viscosity contrast. So when you study folding, buckling of fold, so when you understand buckling processes, you learn that it requires viscosity contrast or competency contrast to form layers or buckle folds. So now let me draw. So if it is more, so now let's try to shear this layer. So what will happen? It will deform very less, but just the opposite, just the opposite, just the opposite. Am I doing it correct way? No, I'm not. Now I hope you are clear. So what will happen here that this will move like this, right? Am I drawing it correctly or incorrectly? What will happen if you have shear? Hmm. So this will go less, and this again will go like this. I hope now it is clear to you. So this is what will happen due to competency contrast. So this is high competence, right? Do you understand? So this area we are having high deformation, right, Sumit? And this area we are having lower deformation. Now come back to the question. Here between A and B, which is which is more viscous, or which is more competent? Or B is more competent, right? This you can understand clear. In C and D, C is more competent. So B and C, there is no option.
Exactly
B.
what my confusion began from.
Okay, so there is some issues in the option. There is some issues in the option. Okay, so now,
Just try to.
understand.
Actually, I got to the base. I mean, the basic idea got quite clear to me, but I was unable to find the right option.
I'm really sorry for that. But this is clear. So I thought that yeah, there was some mistakes. But okay, fine. So A and A is less competent. And B and C is more competent. That's it. Don't get into the rocks. Okay. So I will when I put the questions on this list, I will just correct these options and send it to you. Okay. Let's move. Let's come back to this. So we have, you can see older rocks and younger rocks. Means younging direction is this. This much you understand, right? So minor fold patterns are in the limbs are vertical section is shown. So you can see here. Now let's gather the knowledge you have learned. So what is this? Long, short, long. Here, long, short, long. So there will be two options. Either it will bond here or in the bottom. So to do this, what you need to do, is that you need to understand this vergence, huh? So whether this is clockwise or anti-clockwise, try to think. We just studied couple of slides back. Hmm. So what do you think? Which is clockwise and which is anti-clockwise? You can see long, short, long, right? Long, short, long. This is clockwise. Long, short, long, or long, short, long. Where do you think? Where is S-shaped and where is Z-shaped? Don't you think this is Z-shaped and this is S-shaped, right? This is clockwise and this is anti-clockwise. So if you try to match this, this will come like this. Now try to solve which is which what kind of fold is this? Antiform, synform, anticline, syncline. What is this?
This is informal anticline.
Very nice. Good. Okay. Again, I have kept this. It's fine. What type of fold is typically formed in regions experiencing compressional stress? Compressional stress means, and suppose you have a layer. What do you think? What type of fold will form? We have a lot of questions to cover. Will
Anticline. Anticline.
both, right? Both, right?
Pardon me, sir.
It can form both types of fold, right? Folds. It is possible to form syncline and anticline also. Depends on the Younging and only. So that is not asking here. It is possible to form both type of fold. It can form like this. It can form like this, right? Both is possible. So option C is correct. Okay. Which is not which of the following is not a classification of folds? Symmetric, asymmetric, recumbent, or fractured. What do you think?
Fractured. Fractured. Fractured
Very
is not a
nice.
classification.
Very nice. Good. Which fold type is characterized by fold axis that is horizontal? So based on the fold axis, there are several types of fold. So when you have a horizontal, this is a horizontal fold. So your fold axis is horizontal. So based on the classification of fold axis, option C is correct. I did not kept this image. Actually, there was a diagram that which tells you, if you even if you go to the lectures, the professor has explained that based on the classification of fold axis orientation is will be plunging. If you have a plunging fold, it will be like this. And now if you can have a 90-degree, then you will become vertical fold. Okay. So option C is correct. Isoclinar fold, we know it's based on what? Interleave angle, right? The recumbent fold, it's 0 to 30-degree. 0 to 10-degree, I guess. Yeah. So these are based on the angles. Okay, let's move to the next question. What is superposed fold? We have entered the last section of this topic. Have you
Option
heard
B. Yeah. The option B.
option?
A fold that develops from the interaction of two or more elements.
Very nice. Okay, let's read for option A. Option A, the fold that forms without any prior deformation. No. Correct. That remains unchanged. No. A fold that only occurs sedimentary. No. Yeah. Option B is correct. In the context of superposed folds, what does the term interference pattern referred to? Option A, the visual representation of a single fold, the complex geometries resulting from interaction of multiple folds, the layering of sedimentary rocks, the process of erosion affecting folded rocks.
Complex geometries resulting from the interaction of multiple folds.
Very nice. Okay. What is the primary factor that determines the classification of superposed folds according to Ramsey and Hubbard? So, if you have learned or watched the lectures, or if you have heard about this superposed folding, so we know there are three types of, or even you can say four, right? Type 0, type 1, type 2, type 3, right? There are four types of superposed folding. So, what is that primary factor that that classifies? Tell me. That actually helps you to classify between 0, 1, 2, 4. Okay, do it. I will show you the images. Huh? What do you think? Option A, the age of the rock. Does it depend on the age of the rock? No, right? Does not depend on age of the rocks. Sedimentary environment does not
Option
depend.
C, the angular
Ah,
relation.
right. Correct. It depends on angular relationship between axial and axis and axial planes of the rock. So it depends. I will just show you how it depends. Just give me a second. I will just show you. Okay. Can you see this? So, okay. So this is type 0, type 1, type 2, and type 3. Hmm. So you can see it's based on what? These angles. Angle. This angle, if the this hinge line angle, the plunge, and this axial planar. That is why these options we'll get into more. We'll do some more problems, then you will understand the angular relation between the axis and the axial planes. Okay. So which of the following statements about type 3 superposed folds is true? Option A, they do not create interference pattern. They are characterized by parallel fold axis. They involve significant formation of first fold, significant deformation of first fold. They are the simplest form of the superposed fold. So that is wrong that there is no interference pattern. I will just show you that there are, so where did it go? So type, one second. I've just skipped this, huh? So if you see, type 1 is called dome and basin pattern, type 2 is called boomerang or mushroom shaped, type 3 is hook pattern, and type 0 is fold amplification. So it just simply it amplifies, huh? Type 0, because all these axes and the axial planar cleavage are same. They are oriented parallel to each other. So type 3, let's see type 3. Type 3 patterns, huh? Vertical AB2, horizontal AB2. This is perpendicular, and horizontal axes are parallel. Can you see this? Axes are parallel, right? So they are type 3. In type 3, the fold axes are parallel. So option B is correct. They involve significant deformation first. No. They are the simplest. No. Simplest is type 0. Hmm. Okay. And remember this, these are very important, huh? Dome and basin, the first type, mushroom shaped or boomerang shape is type 2, type 3 is called hook pattern, and type 0 is called fold amplification. Very simple. Huh? So this is type 1, type 2, and type 3. Okay. Let's do a couple of more questions, then we'll end the session. In superposed folding, what is the significance of the angle between the first and the second fold axis? It determines the age of the fold, or it influences the economic value of the folded rocks. It affects the resulting symmetry and interference pattern of the folds. It is irrelevant to the classification of folds. What do you think?
So it is option D. It is oh no, sorry, irrelevant. Sorry. It affects the resulting geometry and interference patterns of the pole.
Very correct. Option C. What type of fold is likely to form in a region experiencing multiple phases of tectonic stresses?
Superposed, monoclines, inclines. Sir, it is superposed.
Superposed because of multiple phases, right? Which classification type of superposed fold is characterized by the original fold structure remaining largely intact?
Original fold remaining largely intact. It is type 0.
Hmm. That's zero. Which, what is the primary challenge in studying superposed fold?
Motivate the surrounding geological structure. Many options appear to be correct.
Hmm.
They are always found in
Hmm.
sedimentary
Primary
layers.
challenge, huh? You have to, when you are not able to solve and you are having some doubts, read the questions again. It's
Okay, okay.
general techniques for any MCQ problem or any type of problems. You read the question again, you will get the hint. It says primary challenge, huh? Primary, main.
Okay. Their complex geometries are difficult to visualize and
Very
interpret.
correct. Right, because it's the complexities of these geometries. You can see, if I show you some images or you go back and try to see the images, it's so complex. You can see just basic. I have just put an image, a very basic one. Hook pattern, mushroom shaped, basin pattern or dome and basin pattern. So they are very complex in structures. So that is why, because of their geometry, it becomes difficult to interpret. And if you have been to the lectures, you must have seen when I think in the next week, I guess you will be seeing many superposed foldings in Tetulanga, study area, Tetulanga. Watch those videos and then you will see how amazing those interference patterns are actually manifested, or it's actually exposed in Tetulanga. Yeah, you want to say something, Sumit?
No, no, no.
Okay. So I think with this, I will end. I hope you must have got something, some understanding, and helped you to clear your ideas, basic ideas of the superposed foldings and classification of folds. And please go back and you know read, watch those lectures and read books. So it will help you to get more better ideas, and your understandings will get more clear about the folds, classification of folds, and the superposed folding. Okay.
Okay, thank you, sir. Thanks a lot.
Thanks a lot. See you in the next weekend. We'll meet in the next Sunday again, 3 to 5 p.m.
This has been just like a one-to-one teaching session. Others are not
Yeah.
actively participating.
So I'm glad at least you are participating.
No, it has cleared my. I think I am gradually improving over the weeks.
You are doing really good. You are doing really good today. I mean, you're so it will help you become more clear, and your concepts will be, clear gradually.
Okay,
Okay.
thanks.
Okay. Okay. Bye.